In this video, we're going to introduce the rule that's called integration by parts. We'll see where that rule comes from and in which case we have to use it. So let's look at this example. Integral of x times cosine of x dx. Now, before we even look into integration by parts method, let's think what we can and cannot do, or I should say what we can try. Now, first of all, let me remind you what we shouldn't be trying, and that is splitting this integral into the product of two other integrals. So there is no rule like that at all when we're integrating. So that's not equal to the integral of x dx times integral of cosine of x dx. So I cannot do that. So can't do. There is no rule like that. Now, what are the official rules that we've learned so far? Well, we know that there is a substitution rule. Let's attempt that. Let's see what we're going to get from there. So let's try the substitution rule. So with the substitution rule, we have to introduce new variable u. We want to decide what u might be within our original function. Well, replacing x itself with u makes no difference, right? So we need to kind of create a bigger part. Well, maybe let's try cosine. So if u equals cosine of x, in other words, if I say, well, that is a new variable u, then I also need to replace all other parts of this integral with the new variable u. So in other words, I need to find differential du, right? To find differential du, we're going to find derivative of cosine of x, which is negative sine x, and then dx. So what it says here is that I can introduce differential du, or put it within my integral, only if I can replace it with negative sine x dx. Well, but when I look at my integral here, I don't have negative sine x. I do have dx, but I don't have negative sine x dx, right? I have x dx, but not that. So that's where we get stuck when we try to use the substitution rule. So that portion we don't have. I don't have that, right? So that's where we get stuck. Well, and that's how we turn to the new method, which is integration by parts. Now, let me tell you the story where that method comes from. It's going to come as a formula, but that's not some kind of magic formula. It's actually pretty easy to see where that comes from. The integration by parts formula comes from the differentiation product rule. Let's refresh how that goes. So if I need to find derivative dx of a product of two functions, let's say f of x times g of x. According to the product rule, what we need to do, we need to take the first function and multiply it by the derivative of the second function, so g prime of x, and then plus the second function times the derivative of the first one, f prime of x. F prime of x. So hopefully you remember that rule. Now, what we're going to do from here, what we'll do, we're going to integrate both parts of that equality. So I'm going to apply integral to the left hand side, I'm going to apply integral to the right hand side. The only thing, I'll switch sides actually. So that I'll put on the right. So in other words, I have integral of the entire right hand side. So integral of f of x times g prime of x plus g of x times f prime of x dx. That's that. And then integral of the left hand side, which is now going to be on the right. Integral of dx f of x times g of x. Okay, and let's see how we can simplify that. Now, on the left-hand side, I have integral of a sum. Now, when we have integral of a sum, that can be split up into two integrals, right? Product cannot be split up, but sum can. So that I can rewrite as integral of f of x times g prime of x dx, that's this first term, plus another integral, and now it's going to be the second term, integral of g of x times f prime of x dx. That's the left hand side. Now the right hand side, so what we can see on the right hand side is that we have integral, which is same as antiderivative of the derivative. So when we have integral and derivative next to each other, they just basically cancel each other, right? It's same as squaring square root, or square rooting a square, right? So they would cancel each other. That means that on the right hand side we only have f of x times g of x. And the last step, we're getting really close to seeing the formula itself. The last step will be to subtract the second integral from both sides. So if I subtract that from each side, then I will obtain the following integral of f of x times g prime of x dx equals, again, we're subtracting this integral, so the right hand side, now it's gone from the left hand side, and it's going to appear on the right hand side. So the right hand side is f of x times g of x minus, since we're subtracting, integral of g of x times f prime of x dx. And that's something I'm going to box, because we're looking at the formula for integrating by parts, or integration by parts formula. This is integration by parts formula. Now it may be a little bit overwhelming and not very clear how to use it, but we'll see all that. If it feels a little bit overwhelming, well, we can actually rewrite it in a little bit simpler form. And to that, we're gonna rename our functions. So let's give them different names and simpler notation. So let's say, let function f be called u, and function g of x, let's call v. Okay, so now I can see that where I have f of x, I can put u, and where I have g of x here, and over here I can write v. But we also have this g prime x dx, right, and then f prime x of x dx, so we need to replace those parts in terms of u or v. So to that, we're just going to find differential of u, differential of v. In other words, du and dv, and that is, I'm going to write like that, so differential of u, so we know that from u substitution method, or from the substitution method, right? So differential of u is the derivative of f dx, so it's f prime x dx, and then differential v is g prime of x dx. And now we have everything we need to rewrite this formula using u and v, or du and dv, including du and dv. So let's see how it's gonna look like now. So I have on the left hand side of the formula, I have integral, then f of x I'm replacing with u. Now g prime of x dx, it's right here, g prime of x dx, I will replace with dv. So in other words, that's where we have derivative of function g, right? Equals the right hand side, f of x times g of x, so it's simply u times v, u v minus, and then this integral will contain g of x, that's v, and then f prime of x dx, that's over here, so that's du, which will represent derivative of function f, right? Okay, so that is the simpler version of that formula, and that's something that we're going to be using in the examples. There's also another way to write that formula, just in different notation. I'll write on the side You can use either one of those two, and you can come across either one of those two as you know, look at different resources. I can also use notation prime. So instead of writing dv, which also means derivative of function v, I can write v prime. So in other words, formula will look like this: u v prime minus, equals u v, or u times v, minus v u prime. Okay, so that's another way to write that formula. Well, how do we apply this formula? So we have it in front of us. It still has, you know, quite a few things going on. How is it going to be helpful? Well, let's go back to that example that we started with, and let's try to apply that formula to that example. So what I did, I copied down the formula, and I copied down that example that we're trying to attempt. This is how we're going to approach it. So our integral should correspond to the left-hand side of the formula. So in other words, one part of our expression we should represent as u, and the other part we should represent as dv, which would mean that it's a derivative of some kind of function. And now, what is what in our integral? It's kind of like a good question. For now, for this first example, we're just gonna kind of follow it in order. So we'll represent x as u, and cosine x dx we're gonna represent as dv. Now, what our goal is going to be is to obtain the right-hand side of this formula, which means that, well, we need to find out what's the right-hand side. It's just u times v minus integral of v du. So in other words, to put together the right-hand side of the formula, we have to know what v itself is. So knowing dv, how to obtain v itself. So we'll talk about that. And then over here, we'll need to have du. Well, we already know what u is, but how do we find du? Well, to organize this work so that we can finish this formula, we'll kind of put everything together over here. So I'll write down what u equals to. Then later I will have to write down what v equals to. But then we'll also have to find du, and here I'll put dv. Now, what I have so far is the following. We said that, well, let u be equal x. So u is x. And then let cosine x dx be dv. So I'm writing it here. That's cosine x dx. So now that's how I have the left-hand side of the formula. And what I'll need to do next is to fill in those missing portions. I need to find du and I need to find dv. Let's first work on u, or du. Now, if we know u, how do we find differential du? Well, we practice that same idea as when we apply substitution rule to find differential du. We just have to find derivative of the right-hand side and write that with dx. So derivative of x is 1, and then dx. So in other words, going this way, so that means that going this way, we need to differentiate. I'll write that. Differentiate. Knowing u, to find du, you differentiate. Now, how do we obtain v? Well, we know dv, right? We know that derivative of v is cosine x. Now, if we know derivative, how do we find the function itself? Well, we need to find antiderivative, right? It's same as to integrate. So going that way, to find v, we'll need to integrate. In other words, find antiderivative. Well, what is antiderivative or integral of cosine of x? That's going to be sine. So sine x. Okay, so once you obtained all pieces, then we can go ahead and continue with the formula. The only thing, maybe I'll just rewrite here that du is technically the same as dx, right? That times 1 will not make any difference. So, or du equals dx. Okay, let's continue with the formula. So equals. Now I'm writing down the right hand side. I have to write u times v. So what is u? U is x, and then times v. V is sine x. That's u v. And then I'll continue here with minus integral. Within that integral I should put v, which is sine x, and du. Well, what is du? Du is same as dx in this case, so it's just dx. That is v, and that is du. By the way, notice that in this formula on the right hand side, within that integral, we have kind of like the opposite things, right? So if it's u dv on the left hand side, then on the right hand side is v du. So that's how you can remember the formula, and that part is simply u times simply v. Okay, so what do we have now? Is we can notice by applying this formula, integration by parts formula, we haven't obtained the final answer yet. However, what happened is that the integral on the right hand side is much simpler integral, right? It's just the basic integral. So we have no problem integrating sine of x. So let's see what we'll get. X sine of x, that is product, and then minus. Now, once again, integral or antiderivative of sine of x is it's negative cosine of x. Negative cosine of x. And of course, since I integrated and I have indefinite integral here, I have to write plus c. I'm like out of the room here, but I'll put here plus c. Now, be careful, I have two negative signs here, one from the formula and one from the rules of integration, right? I'm going to rewrite the answer. X sine of x plus, minus and minus will give me plus, cosine of x plus c. And that's going to be the final answer for this problem. So that's how we integrate using the integration by parts formula.